divided this topic into two parts, part 1 and part 2. So today I'm going to give a lecture on the part 1 for road and pavement. Because if I give a lecture for both slides, it will consume a lot of time and it will be quite heavy for you guys to digest all the knowledge from both parts. Okay, so without delaying any time, for the learning outcomes for today's class is to distinguish, at the end of this lecture, you are able to distinguish between low and high volume road. So what is low volume road and what is high volume road? And then also you are able to explain the road location considerations and what are the processes involved. And then last one is to explain the pavement concept and materials that usually be used for road project. Okay, so I'm skipping this part. Oh, okay. So before we go further into details, I'm going to discuss a little bit on how the road construction or road project can affect our nation's economic growth. Okay, so the development of each of country depends on connectivity of various places with adequate network. So that network is actually a road lah. Okay, it's actually a jalan. Okay, so roads are the major channel of transportation, usually being used for carrying goods. Okay, any goods, any materials, and then for carrying passengers as well. So they actually play a significant role in improving the socio-economic standard of a particular nation or particular country. And then roads constitute the most important mode of communication, okay, in areas where, let's say, railways, okay, jalan kereta api, railways have not developed and form the basic infrastructure for the development and economic growth of the country. So the road is the benefit. Okay, the benefit from the investment for a road project or a road construction are indirect and have a long-term effect, and not immediately visible. So actually, roads are very important asset for a country because it can affect the economic growth of that particular nation. So, however, merely creating this asset is not enough. It has to be planned carefully. Dia punya planning stage should be well monitored and then well planned, and then it has to be planned with a good managing system. And a pavement which is not designed properly, it can deteriorate fast lah, senang nak rosak. Okay, kalau kita tak design the road in a proper or using the specification, the right specification, so dia akan rosak dengan cepat. Before we go into details on what is pavement and then what is a road, so for your information, in India, okay, for example, in India, India is a large country that having a huge resource of materials for road construction. Okay, so there are various types of pavement which differ in their suitability in different environments. So different environment require different design or different materials for pavement. Okay, so each of the type of pavement dia mempunyai advantage and disadvantages. So what is road? So road, kalau kita translate, okay, direct translate is jalan lah. Okay, a road is a jalan. So what is actually road by definition. So some define road as is a pathway, ataupun is a route or is a way on land. Okay, dia mesti atas tanah between two places that has been paved or otherwise improved to allow travel by foot, some form of conveyance, and including a motor vehicles, bicycles, kuda, so anything lah. So that is a road to to commute, okay, people from one place to another place. So that is a road. So it depends. Jalan tanah pun dikira sebagai jalan, okay, jalan batu pun dikira sebagai jalan. So dia tak kisah what kind of materials that you are using, as long as they achieve the objective of commuting people from one place to another place, is considered as a road. So pavement can be defined, okay, from the civil engineering perspective, from the civil engineering area. So pavement is a durable, it's a strong surface of a road. And then the primary function of pavement is to transmit beban, okay, to transmit a load to the subbase, to the layer beneath the soil. So modern flexible materials, modern flexible pavement contain sand, okay, dia mengandungi sand, gravel or crushed stone, batu ataupun batu yang dah dipecah-pecah into smaller piece, and then it will be compacted with a binder. So dia ada satu materials that we call as a binder untuk melekatkan, to mix together the sand or the gravel together, and then the binder usually is from bituminous material. Bituminous material ni selalunya kalau kita lihat yang color hitam, okay, dekat jalan tu kalau kamu lihat tar, okay, tar adalah bituminous materials. So what are the bituminous materials? For example, for bituminous materials are asphalt, tar, ataupun asphaltic oil. Okay, so a pavement that has enough plasticity to absorb shock. So the rigid pavement are made of concrete, composed of coarse and fine aggregate. So I'm sure that you are aware of what is a concrete. So concrete is a mixture of coarse aggregate, fine aggregate, cement, and water lah. So when we are using rigid pavement, that is the materials needed. So for flexible materials, so we are using the bituminous materials mixed together with sand and gravel or crushed stone. So that is pavement. So for rigid pavement, additional info for rigid pavement, after we have mixed together all the coarse aggregate, fine aggregate, Portland cement, water, and then we also usually use the reinforcement bar, okay, ataupun steel rod, okay, to ensure that the materials of rigid pavement is in a good condition, okay, is strong enough to uphold the load above it. So continue to the next slide. So this one, okay, I have explained what is a road. Okay, this is an example of a road. I believe that you are all aware what is road. Okay, so road. So road can be classified into two. So the first one is low volume road, and then the second one is high volume road. So some of the definition define low volume road as average daily traffic of 1,000 vehicles per day or less than 1,000. So that is low volume. And then for high volume road, so average daily traffic is more than 1,000 vehicles per day. So in simplest way to define the low volume road is usually the low volume road be constructed at a remote area. Okay, selalunya berada di luar kawasan lah, macam di kawasan perkampungan. Okay, kawasan yang jauh daripada bandar ataupun di pesisir bandar. And then for high volume road, it's actually being constructed in center of the city, such as macam highway. Okay, that is a high volume road where more than 1,000 users using that road a day. So low volume roads provide the primary link to the highway transportation system lah. So usually low volume road ini dia akan menghubungkan daripada satu kawasan yang agak terpencil ke kawasan bandar. Okay, that is a low volume road. So they provide links. Okay, they provide links from home or from any shops that are situated or located far from the city. Okay, and then they provide public access to essential health, okay, for health purpose, education, and then so on and so forth. So the low volume road link between raw materials and market is critical to economics locally and nationally in all countries around the world. So many of the low volume roads around the world, they consist of a single lane. Kebiasaannya memang dia buat single lane, and then with gravel or even native surfacing. So selalunya dia akan menggunakan batu-batu lah ataupun any materials, natural materials such as soil ataupun batu. In some remote area in the world, low volume road follow travel routes many centuries old. So maksudnya dah lama telah dikonstruk tetapi masih menggunakan material dari punca natural resources. And then in developing areas, so low volume road may be the first step from human, or there may be all new roads transporting natural network with low conventional design standard. So kalau kita lihat perbezaan antara low volume road dan juga high volume road, the design is different, it's not similar in terms of the design, because the design for high volume road memerlukan spesifikasi yang tinggi disebabkan oleh bebanan yang terhasil daripada kenderaan yang menggunakan jalan tersebut berbanding dengan low volume road, because less traffic ataupun less vehicles that are using that road. So the fewer the road user, semakin sikit pengguna jalan raya, so the less funding is available for road maintenance and restoration. So meaning to say that apabila sesuatu jalan tersebut di lokasi tersebut, jalan tersebut tidak mempunyai ramai pengguna, maka funding untuk maintenance work, okay, ataupun repairing works akan dikurangkan. Okay, that's why apabila kita lihat jalan-jalan di low volume road yang kadang tidak terjaga, okay, the maintenance work is being compromised, okay, kalau compare dengan jalan-jalan di high volume road. But what we can see dekat Kuching, okay, usually high volume road pun also they are not maintaining it in a proper way. So sometimes it will take a long time for them to do the maintenance work. For example, dekat on the way to Kota Samarahan, okay, dekat McD Tabuan Jaya tersebut, jalan rayanya memang agak kurang memuaskan. Okay, selalu kita akan lihat defect dekat jalan tersebut, walaupun jalan tersebut telah dibina, di resurface, tetapi dalam jangka masa yang pendek defect will occur. Okay, that is because of the soil condition of that particular area, especially in Sarawak, di mana soil kita ini mengandungi what we call peat soil. Okay, so peat soil is one of the soil that is weak. Okay, dia tidak kuat. So apabila tanah tersebut tidak kuat, maka jalan tersebut akan selalu rosak. Okay, akan selalu ada defect. So that is the low volume road. Okay, so for high volume road is is the opposite way of low volume road, because low volume roads is they cater a high volume of vehicles per day. And then some of the authors define low volume road. Okay, some authors kadang-kadang ada orang yang define the low volume road is less than 300 vehicles per day, and then more than 300 vehicles is considered as high volume. Okay, tapi ada juga yang define as less than 1000 is low, more than 1000 vehicles per day is considered as high volume road. So different people have different definition lah. So either way is okay. All right, so that is about the low volume road and high volume road. Okay, this is the example for high volume road. As you can see at the slide, the left side of the slide shows that is a high volume road where you can see the traffic is quite congested with a lot of vehicles. Okay, and then for the right side of your slide indicates the low volume road. So how does it looks like the low volume road? Okay, memang kecil penggunaannya, tidak ramai, less road users. So road local considerations, location consideration. So to consider a location for a road project ataupun alignment of a new road project, so the traffic planner from various studies can predict the effect of travel patterns of alternative location proposed highway. Also, they analyze the probable effect of new link in highway network, and then this permits the location engineer to determine how well alternative location will fit with the existing network. So let's say you dah ada satu laluan sekarang, kita ambil contoh daripada Kuching ke Semarahan, kita ada satu laluan yang dikira sebagai shortcut lah, okay, menggunakan jalan daripada Tabuan ke Kota Semarahan. Kita juga mempunyai satu lagi alternative link, alternative network, which is we can access to Kota Semarahan through Batu 7 and then also through Batu 13. So let's say now kita nak buat a new location for a new alignment of a road project from Kota Semarahan to Kuching ataupun from Semarahan to Petrajaya, because what we can observe nowadays the traffic is quite congested during the peak hours lah, okay, during masa pergi kerja and then balik kerja. And then when we want to propose something new, location of a new alignment of a road, so these are the consideration that we have to taken into account. So the first one is we have to ask ourselves, so what is the purpose of the road? So apakah tujuan utama kita nak membina jalan tersebut? So adakah ia sebagai alternatif road kepada jalan yang sedia ada, ataupun ia merupakan a new alignment, a new road ataupun a new link from one place to another place. Contohnya macam kita lihat baru-baru ini, the construction of a new road from to Kapit. Okay, sekarang ni to Kapit kita dah ada a new alignment, okay, satu jalan yang menghubungkan daripada Sibu ke Kapit. Okay, so we have to ask ourselves the purpose of having the road. Okay, sama ada ia akan menguntungkan ataupun memberi efek kepada socio-economics ataupun social impact, and then ataupun adakah ia tidak memberi apa-apa impact kepada negara ataupun penduduk-penduduk di sekitar kawasan tersebut. And then the second one, what we have to take into account is what is the nature of the terrain over which the road must pass. So maksudnya kita kena tahu apakah keadaan the ground condition ataupun the topology of the topology area, okay, untuk kawasan yang kita nak bina jalan tersebut. So adakah kawasan tersebut melalui kawasan berbukit ataupun kawasan bergunung ganang, and then are we going to construct a new road dekat dalam hutan? Okay, kalau dalam hutan, adakah ia akan it will involve forest reserve? So that one kita kena tahulah apakah keadaan di sekitar proposed construction of a new road alignment. So apabila kita dah tahu, when we already know what are the nature of the ground condition dekat the new location of a road construction, then we can identify what are the works that we have to cater or to tackle on. So the third question is, does the road pass through sensitive ecological or protected zones? So this one, as I said before, adakah yang akan melalui satu kawasan yang amat sensitif ataupun yang protect, yang telah dikawal, dikawal selia oleh Jabatan Hutan kah, ataupun dikawal selia oleh our state government. So contohnya saya nak share saya nak share dua situasi when I was with the LBU previously constructing Penbonyo, a new upgrading and constructing a new alignment from Serian to Pantu Junction. So we did encounter a few problems where the alignment that being proposed by the engineers, dia melalui kawasan perkuburan dekat Balai Ringin, kalau tak silap, that is perkuburan orang-orang Kristian, on the way from Balai Ringin to Simunjan interchange. So apabila berlakunya sensitif ecological ataupun sensitif area seperti tanah perkuburan, so we have to bear in mind that we cannot involve that area into our new alignment. So what we did was we have to relocate the alignment of the road into somewhere else. So maksudnya kita ubah sikit dia punya alignment. Okay, kalau dia melencong terlalu kuat, kita akan ubah sikit supaya ia tidak melalui tanah perkuburan tersebut. And then the second one is what we encountered was the alignment that been proposed by the engineer, dia melalui kawasan hutan simpan, forest reserve, which we call as a Sabal Forest Reserve. So apa yang berlaku ialah from the Jabatan Perhutanan Malaysia, Sarawak, Jabatan Perhutanan Sarawak, they preliminary they don't allow us, they didn't allow us to construct a road that across the Sabal Forest Reserve. Mereka suggest that why don't you build a tunnel dekat dekat that particular area. So apabila they suggest something like that, we anticipate that it will cost a lot. Okay, kalau you nak buat a tunnel, ia akan mengakibatkan cost semakin naik. So what we did was we seek for approval untuk menebang sedikit sahaja kawasan, which we relocate a little bit of the alignment, and then we seek for approval to cut down some portion of the forest reserve, Sabal Forest Reserve. So that was happened during my time at LBU dulu lah, in Penbonyo construction. And then after all, they did give us the approval to do the pembalakan sikit lah dekat kawasan forest reserve. Okay, all right. So the fourth question that you have to ask yourself is, so what road building materials are available? So maksudnya sekarang kalau you nak buat jalan, you must know what are the materials that you should consider into your project. So now we have a lot of materials, when you're going to construct a road. So it's either you are going to choose flexible pavement ataupun flexible road, ataupun you are going to choose the rigid pavement. So both requires different types of materials. So you have to know that you have to do some survey. Is it the materials are easily available dekat kawasan tersebut ataupun susah nak cari? Is it hard to find the materials? So apabila kita susah, okay, let's say you want to use a flexible pavement where you want to use the asphaltic ataupun bituminous pavement. So let's say dekat sana tak ada. Okay, what you can do is you have to set up a new plant. We call it as a premix plant. Okay, di mana plant tersebut akan manufacture ataupun dia akan menghasilkan ataupun dia akan membuat that particular building materials, which is the tar lah, okay, the asphalt tar. So and then number 5 is what construction expertise is available. So doing a road project requires people that obtain ataupun exhibit expertise, okay, ataupun experience in that particular area. So contohnya kalau kita nak buat road, make sure we have a road expertise dalam tim kita lah. So you cannot appoint someone who have 20 years experience in building works, okay, tetapi tak ada pengalaman ataupun they don't have any experience in doing road works. So because road works is require expertise, okay, kita memerlukan orang yang betul-betul pakar, okay. That's why when we construct the Plan Borneo, most of the expertise we import them from Semenanjung Malaysia lah, because Semenanjung Malaysia they are they have construct a lot of highway ataupun jalan, and then we also requires expertise that have the experience from the overseas, okay, untuk to ensure that our project can be delivered in a proper manner, in a proper way, okay, so they can execute the project, they can consult the client, and then also they can solve any problems that arise during the construction period. So that's why it is very important for us to have a very expert engineers ataupun any parties, okay, which have a broad experience in road construction. And then number 6 is what road construction equipment is available. So it depends on the types of pavement that you are choose. Okay, sama ada you nak guna flexible pavement or you want to use a rigid pavement. So kalau for rigid pavement, different equipment ataupun machineries akan digunakan. Okay, so contohnya dia akan menggunakan paver, dia akan menggunakan compactor, and then for rigid pavement, it requires different types of equipments and machineries. Okay, so that's why it depends on types of pavement that we're going to construct. And then number 7 is what are the capabilities of the vehicles to use the road. So kita kena lihat semula adakah jalan tersebut akan digunakan oleh vehicles yang yang besar-besar seperti lori kah, okay, ataupun yang digunakan oleh kenderaan biasa. Okay, so if that alignment ataupun that pathway will be used by the heavy vehicles, then the design of the pavement should be relevant to the vehicles, okay, that will use the road. So kalau kita hanya provide that particular alignment ataupun pathway for common vehicles ataupun light vehicles, so the specification should be lesser lah than the heavy vehicles. So these are 7 considerations apabila you nak identify the location of the road, okay. So bear in mind, this is the road location consideration, okay, not the design consideration. This is only for you to identify the proper location for your road project. Okay, so the next one is a road location process. So tadi kita berbincang, we discuss on the consideration that should be taken into account. So for this slide, kita akan discuss on, we shall discuss on the road location process. What are the processes involved? Okay, apabila you nak buat nak identify the road location. So the first one, when referring to this slide, which is the office study. So actually office study is the first phase. Okay, ia adalah fasa pertama, which is the preliminary stage in any road ataupun highway location study. So the examination of all available data of that particular area which the road is to be constructed. Okay, so this phase is actually carried out in the office. Okay, nama pun dah office study. So usually we carried out this one in the office prior to any field, okay, or photogrammetric investigation. So before we go into the field, so kita akan buat dekat office dahululah. Okay, so all the available data are collected and being examined. Kita akan collect data and then kita analyze, kita akan examine the data. So this data for office study tadi can be obtained from existing engineering reports ataupun we can existing maps, aerial photograph, ataupun any data lah, carta ke apa kan, so which are usually available at one or more of the State's Department of Transportation. So kalau kita nak dapatkan data, kita boleh minta daripada Department of Transportation negeri tersebut lah, okay. Ataupun kita boleh dapatkan daripada geologi, okay, Jabatan Geologi, Jabatan Hidrologi, ataupun Jabatan Agriculture, okay. Kita boleh dapatkan data-data yang berkenaan lah, okay. So the type of amount of data collected and being examined is depend on the type of road ataupun highway that you are being considered. But in general, data should be obtained that should include this a few characteristics, a few components, which are, the first one is engineering perspective. Okay, the data should include the engineering perspective, which includes the topography of the area, the geology of the area, the climate, and also the traffic volumes. Okay, kita kena consider that is from the perspective of engineering, civil engineering. So from the social and demographical, also it include the land use and zoning pattern. So kita kena tahu apakah kegunaan tanah-tanah tersebut, initially current land use of that particular area, and then how it being zoned, the pattern of the zoning system ataupun the zoning style of the location. So number 3 is the environmental. Okay, this one is very important also for environmental. So adakah yang include the wildlife. Okay, contohnya kalau kita melalui hutan, kita kena tahu apakah kehidupan ataupun hidupan liar yang ada di kawasan tersebut supaya kita tidak mengancam, okay, memberi ancaman kepada mereka. And then the historic part, okay, contohlah ada benda-benda yang bersejarah dekat tempat tersebut, so kita kena consider lah, kita kena dapatkan data-data. And then adakah ada possible effect of air pollution, noise pollution, or water pollution having when we are going to construct the road, okay. And then from the economic part, it include the unit cost for construction, of course. Okay, kita mesti lihat berapakah cost yang diperlukan. Okay, apakah cost which include in the proposed road construction. And then preliminary analysis. of the data obtained will indicate whether any or the specific site should be excluded from further consideration. So apabila kita dah dapat data-data tersebut, kita dah dapat a few idea, a few preliminary view. It's either we can exclude the site from further consideration, ataupun kita boleh proceed terus dengan apa yang kita nak buat. Okay, for example, if it is found that a site of historic and archaeology, contohnya benda dekat tempat tersebut yang mengandungi barang-barang yang barang-barang sejarah ataupun archaeological importance is located within the area, so it may be immediately decide, we can decide that any route that traverses the site should be excluded from further consideration lah. Okay, so at the completion of this phase for this office study, the engineer will be able to select general areas through which the highway can traverse. Okay, so maksudnya apabila kita dah buat, kita dah dapatkan all the data, we have analyzed all the data, then we can come up with new findings. Okay, from what we have analyzed. Okay, so either we can use that location, or we just forget about it. Okay, all right, so that is the first process, which is office study. So we go to the next process, which is field reconnaissance. Okay, actually the object of this phase of the study is to identify several feasible routes, each within a band of a limited width of a few hundred meters. So maksudnya sekarang ini kita nak tengok sama ada kita ada alternatif lain ataupun tidak, ataupun feasible routes ataupun tidak. Okay, with around the proposed location. Okay, when roads are being considered, so there is often very little or no information available on maps or photograph. Okay, contohnya kita nak buat sesuatu di kawasan yang betul-betul dalam kawasan pedalaman, so most of the information is not available. Okay, and therefore aerial photography, okay, kita nak ambil gambar daripada atas lah, is widely used to obtain the required information. So sekarang ni kita ada satu sistem that we call as a LiDAR system, where kita hanya ambil gambar daripada atas, the aerial photography, and then they can scan, dia akan scan along the way, and then dia akan terus buat satu 3D ataupun actual the condition of the site. Okay, itu adalah the latest technology. So kita menggunakan teknologi tersebut LiDAR apabila kita nak buat a new alignment for Pen Borneo lah. Okay. Right. So what are the information that usually being collected for field reconnaissance is the first one adalah the terrain and soil condition, of course, the ground condition or the soil conditions of the location, and serviceability of route to industrial and population areas, adakah mempunyai kemudahan sepanjang of the route lah, okay, to industrial and population areas, and then crossing of other transportation facilities such as river, railroad or other highway. Kita kena lihat semula sama ada ia akan melibatkan ataupun ia akan berentasi transportation facilities yang lain seperti sungai ataupun railway kah, ataupun highway kah, existing highway. Okay, and then directness of route. So control points. Okay, what is the directness of route? It's a control point between two terminals are determined for each feasible route. For example, a unique bridge site with no alternative may be taken as a primary control point. Then the feasible routes identified are then plotted on photographic base maps. So that are a few considerations for field reconnaissance. Okay, and then the third one adalah route survey. Okay, and then location survey. So actually this one can be considered as preliminary survey, okay, untuk route survey. and location survey. This is a prelims survey. So during this phase of surveying, so the position of the feasible route that being considered in the field reconnaissance stage are set as closely as possible by establishing all the control points and determining preliminary vertical and horizontal alignment for each. So preliminary alignments are used to evaluate the economics and the environmental feasibility of the alternative routes. So the first one is economic evaluation perspective. So economic evaluation of each alternative route is carried out to determine the future effect of investing the resources that is necessary to construct the road ataupun the highway. So what is the benefit cost ratio method is used for this evaluation. So, and then we have to consider the factors that usually taken into consideration, include the road user cost, and then the construction cost, the maintenance cost, and then road user benefit ataupun disadvantages or benefits of this proposed works, and then also which may include the adverse impact due to dislocation of families, business, and so forth. So, for example, this result that we obtain from this prelim survey, we provide information on the economic resource ataupun economic resources that will be gained or lost if a particular location is selected. So, kalau kita memilih sesuatu alternative route ataupun a new location of a proposed highway ataupun proposed road construction, so kita kena tahu apakah what are the future effect of that construction project. So adakah ia akan mengganggu ekonomik, adakah ia akan mengganggu kesejahteraan penduduk-penduduk setempat. So you have to to consider that, you have to bear in mind that these are also should be taken also. Okay, and then it's either you gain or you lost. Sama ada kita dapat duit, you can benefit some economic growth ataupun kita tak dapat benefit of that. And then the second one is the environmental evaluation. So tadi kita lihat daripada economic evaluation. So sekarang ini kita nak tengok daripada segi environmental evaluation. So the environmental evaluation of construction of a highway ataupun a road at any location will have a significant impact on its surrounding. Okay, so we are talking about the environment lah. So not on the social economy. So a highway is therefore is undeniably is integral part of the local environment and must be considered as such. So this environment includes plant, okay, haiwan, plant, animals, and also human communities, and encompass the social, the physical, the natural, ataupun man-made variables lah, okay, dekat surrounding the location. So these variables that includes of social, physical, natural, they are interrelated in a manner that it maintains the equilibrium and sustain the lifestyle of the existing different communities. Okay, so itu adalah perkara-perkara yang kita perlu lihat. Okay, and then the construction of a highway at a given location may result in significant change in one or more variables. Okay, so which in turn may offset the equilibrium and result in significant effect on the environment. Itu adalah salah satu faktor-faktor yang kita perlu lihat dari segi environment evaluation. Okay, so when we talk about environment, okay, so a lot of things that should be tackled. So we deal with a lot of local authorities to ensure that all the environmental aspect can be preserved. Okay, sebaik yang mungkin lah. Okay, as far as we can. And then before we are going to construct, so a lot of environmental issues ataupun environmental parameters should be included in the project untuk mengelakkan to avoid pollution lah, okay, to avoid pollution to the existing condition of environment surrounding the area. So the last one, we can conclude after we have done the preliminary survey, which is consists of route survey and location survey. And then the final one is the final location survey. So this one, it detailed layout of the selected route, okay, and then during which time the final horizontal and vertical alignment. So kalau kita nak buat jalan, it involve horizontal and vertical alignment lah. So kita ada mendata dan kita akan ada yang menaik. So menaik itu di kawasan yang berbukit lah. Alright, so during time the final horizontal and the vertical alignments are determined, have been identified, and the final position of the structures and drainage are also determined. So the conventional method that usually being used is first to set out the points of intersection ataupun junction lah, intersection junction. So of the straight portion of the highway, and then to fit it to a suitable horizontal curve between this. So maksudnya apabila kita nak buat something that relates to intersection, so kita kena tahu apakah the curve, okay, kita tak boleh simply design curve ikut suka hati kita, tak boleh. Okay, sometimes people question, kenapa jalan ni curve dia terlalu kuat? Why not the consultant engineer design should be a straight road instead of having so many curves. So there are a lot of factors ataupun a lot of reasons why the designers ataupun the civil engineers, consultant ataupun the designer of the alignment come out with that design. Okay, banyak benda dia ambil kira lah. So you cannot simply design, okay, tak apa kita buat jalan lurus saja, tak boleh. Okay, that is not a proper way to design alignment for a road. And then the curve template ataupun the curve design is should be looked into a different standard scales. So different curve may require different consideration. So that this one is very technical part lah. So this one memang under the responsibility of civil engineers ataupun the designer of the alignment. Okay, so those are the processes that involve in locating a road. Okay, kita nak locate a road project. So I think that one is very straightforward. Okay, so this one is the explanation for each of the processes yang involved dalam road location. Okay, you can read it kelak lah. Okay, I have give you, I think it's a very detailed explanation. So this one you can read after this. Okay. All right, so we move to the next subtopics, which is the pavement concept. Okay, so when we talk about pavement, it is a durable surface. Okay, seperti yang saya dah cakap tadi lah. As I said before, pavement yang membezakan pavement dengan road adalah pavement is something that being placed on top of a road, on top of a pathway, on top of a platform that have durable surfacing. Okay, dia mesti surface yang kuat, yang boleh menampung beban yang tinggi. So pavement ataupun ataupun kita bercakap ataupun berbincang berkenaan dengan highway pavement, so it's a structure that consists of superimposed layers. Okay, dia ada layer-layer yang yang terlibat, and then the processed materials above the natural soil subgrade. Okay, the lowest layer of a pavement adalah subgrade. Okay, ingat, kalau orang tanya kamu what is the lowest layer of a pavement, it is called as subgrade. So subgrade ini boleh the subgrade is from soil, okay, tanah yang telah dikompact. That is subgrade. So whose primary function is to distribute the applied vehicle load to the subgrade lah. So pavement, ingatlah, pavement is a durable surfacing which transfer ataupun transmit a load from the vehicles to the subgrade layer. Itu adalah pavement. Okay. So the pavement structure should be able to provide a surface of acceptable riding quality, and then in adequate skid resistance. Okay, the surface should be resist to skid. So kalau ia terlalu licin, ia akan membahayakan pengguna jalan raya. And then the third one adalah favorable light reflecting characteristic. So dia mestilah ada unsur-unsur reflektif. That's why apabila kita lihat jalan raya, kita ada line cat color putih ke, cat color kuning that can reflect during the night time. Okay, and then the ultimate aim is to ensure that transmitted load stress due to wheel load are sufficiently reduced. Okay, dia nak reducekan stress on the load from the vehicles ataupun the heavy vehicles above it. So there are two types of pavement that are recognized as serving this purpose, which is the flexible pavement, and then we have a rigid pavement. So please remember, there are only two types of pavement. Yang pertamanya adalah flexible pavement, yang keduanya adalah rigid pavement. So please remember, okay, please ingat sampai bila-bila. So pavement ada dua, rigid atau flexible. So pavement yang awak selalu lihat dekat jalan raya itu adalah flexible pavement. Jalan yang awak cakap tu, okay, jalan tar, bukan jalan Tunku Abdul Rahman lah, jalan tar, TAR, is considered as flexible pavement. Okay, kalau rigid pavement, if a rigid pavement, they are mainly made from concrete and reinforcement bar ataupun steel bar. Okay, so different types of pavement have different types of functions and different types of failures. Okay, and then when we in what situation we can use rigid pavement, in what situation we can choose flexible pavement. So kedua-duanya ada ciri-ciri yang ataupun kelebihan-kelebihan tersendiri, and then kedua-duanya ada keburukan ataupun disadvantages yang tersendirilah. So requirement of a pavement. So we need to know what is the requirement of a pavement. So an ideal pavement, so pavement yang terbaik should have a few requirements. So the first requirements that should be incorporated to a good pavement is sufficient thickness. Okay, ketebalan pavement mestilah cukup. Okay, kalau awak nak construct jalan with less thickness of standard thickness of JKR, contoh JKR requirement, JKR specifications, automatically pavement awak cepat rosak. Okay, that is the first thing. Sebab apa sufficient thickness? Kalau thickness yang mencukupi, ia akan dapat distribute the load from the wheel of your vehicles to a safe value to the subgrade of the soil. Okay, thickness mesti cukup. Yang kedua, the second one is structurally strong to withstand all types of stress imposed upon it. So dia mestilah durable, dia mestilah cukup kuat untuk menampung apa-apa jenis load, apa-apa jenis bebanan yang dikenakan ke atasnya. That is the second one. The third one is adequate coefficient of friction to prevent skidding. So maksudnya surface awak, pavement awak mestilah have the friction consistency ataupun efficiency. Sebab apa? Kalau dia mempunyai friction yang bagus, kadar kemalangan ataupun kadar kemalangan yang diakibatkan oleh licin, skidding itu akan boleh dikurangkan. Okay. And then the fourth one adalah smooth surface. It doesn't mean that smooth surface dia akan licin. Tak. Okay. Smooth ini kita lihat sebagai the apa nama sama ada permukaan, the surface is really align ataupun dia memang rata lah, okay, tak ada bonggol-bonggol. Okay. So apabila smooth surface also dia akan boleh memberikan keselamatan yang lebih kepada road users, especially even at the high speed. Okay, contohnya kalau you drive 160 km per hour, okay, you drive and then tiba-tiba ada satu part of that road dia ada macam ada bonggol sikit, so automatically awak akan accident. So that's why we better have a very smooth surface to avoid from accident from happens lah. And then the fifth one adalah to produce least noise from moving vehicles. So that's why pavement awak kalau kita lihat kalau awak menggunakan jalan yang berbatu, bunyinya lebih bising kalau awak compare dengan kalau kita menggunakan tar, jalan tar. Okay, so it will produce noise kalau awak menggunakan materials yang that is not proper, proper in a proper selection. Okay, and then the next one, the sixth factors ataupun requirements is dust-proof surface so that traffic safely is not impaired by reducing visibility. Kalau kita lihat dua jalan raya menggunakan tar, jalan raya menggunakan batu-batu kecil. So automatically awak akan lihat jalan raya yang menggunakan batu kecil dia akan menghasilkan ataupun they will produce a lot of dust. Okay, apabila debu-debu ni terangkat pergi ke permukaan atas, maka kadar visibility, kadar penglihatan awak akan berkurang. So you are not able to see clearly on what is in front of you lah. Okay, and then the seven requirements is the impervious surface so that the subgrade soil is well protected. Okay, this one is quite very important also. Awak mestilah ada impervious surface. Impervious surface adalah surface yang tidak menyerap air. Okay, dia lebih kepada resist to water lah. Okay, so apabila pavement awak tersebut, pavement itu sendiri is permeable, air sedang masuk, okay, dia akan masuk daripada atas, daripada tar tersebut, dia akan turun pergi ke layer subbase, dan dia pergi ke road base, dan dia pergi ke subgrade. So apabila air tersebut masuk ke dalam subgrade, which is the lowest level of your pavement, so dia akan mengakibatkan tanah tersebut menjadi tidak kuat. Okay, dia akan lemah, dan apabila lemah dia akan ada settlement. So that's why apa yang berlaku apabila awak lihat there are certain area that ada tiba-tiba ada lubang besar, okay, tanah runtuh, lubang dekat tengah-tengah jalan, that is because of the water that has been seeped through into the subgrade level. Okay, so that's why kita mesti ada surface yang betul-betul can resist the water lah. Okay, and then last one is the long design life with low maintenance cost. So sometimes there are a few projects, okay, there are a few clients that require the project to be murah lah, okay. So the project cost will be lesser, but the maintenance cost-nya akan tinggi. So sometimes we should consider this one. Apabila kita nak buat jalan, better we design lebih sikit lah daripada what it's supposed to have. Apabila kita lihat, kalau kita terlalu budget sangat ataupun kita terlalu berkira on the project cost, maka ia akan mengakibatkan kerugian pada masa hadapan. So which is the maintenance activities. Okay, so you will have to spend a lot on the maintenance. Okay, it's lebih kurang sama lah. Better you do something that is have a long life design rather than you want to maintain. Contohnya dalam masa setahun awak dah kena maintain dah banyak lubang. So itu adalah antara requirements that should have in a good ataupun in a proper pavement types. Okay. So next slide is road cross section. Saya tertinggal lah road cross section. It's okay. Later I will put it dalam elip what the road cross section looks like. Okay, so we move to the types of pavement. Seperti yang saya bagi tahu tadi, we have only two types of pavement, which is rigid and flexible. So the pavement can be classified based on the performance of in terms of the structural, which is the flexible and the rigid pavement lah. So in flexible pavement, wheel loads are transferred by grain to grain contact of the aggregate through the granular structure. The flexible pavement having less flexural strength act like a flexible sheet. Okay. On the contrary, in rigid pavement, the wheel loads are transferred to the subgrade soil by flexural strength of the pavement itself, and the pavement acts like a rigid plate. So maksudnya kalau rigid plate tersebut dia the whole thing dia memang bertindak sebagai satu komponen. Okay. Unlike the flexible, it is different from one portion to another portion of the pavement. Okay, and then in addition to this, the composite pavement are also available. A thin layer of flexible pavement over a rigid pavement is an ideal pavement, which is more desirable characteristic. Okay, sometimes kita akan combine rigid and flexible. So maksudnya apabila you dah buat rigid pavement, you have constructed the rigid pavement, and then you will apply flexible pavement on top of the rigid. So maksudnya you dah settle the concreting part of the rigid pavement, kamu akan lay satu lagi layer menggunakan tar, which is flexible lah. Okay, that is we call as a composite pavement, where we combine both system into one project. Okay, for your information, dekat Kuching kita ada satu portion. I observe lah. Okay, what I have observed before this, there are one location that apply the composite pavement, which they combine flexible and rigid pavement. So kalau kamu tahu the traffic light dekat Tabuan Fuchau, okay, simpang 4 simpang 4 Tabuan Fuchau dekat Phoenix Gym, kawasan tersebut memang selalu mempunyai masalah jalan yang selalu ada defect. Always have a defect, always deteriorate because of the soil condition. So what they did was they do some new construction. They scrap all the pavement, the existing pavement, both sides lah, pergi dan balik. Dia tidak sepanjang jalan, dia only dekat maybe 100 meter from the traffic light, and then dekat junction itself simpang 4, and then 100 meter dekat depan lagi lah. So they scrap all the existing pavement. Okay, they korek habis, and then they do the new subgrade level, and then they construct a rigid pavement. Okay, rigid pavement kat bawah tersebut, and then after they dah buat rigid pavement, then they put another layer of flexible pavement, which is the asphaltic material lah, the tar lah. Okay, they lay the tar, and then that's all. So because of the soil condition, so apabila terjadi soil, you must remember, apabila terjadinya keadaan seperti tersebut, di mana jalan raya kamu mudah nak rosak, mudah kita panggil sebagai rutting, 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 itu adalah one of the defect, the road defect, disebabkan oleh soil dekat bawah itu memang weak condition of the soil. So awak kena pakai rigid pavement. Okay, selalunya benda tersebut berlaku dekat junction. Sebab apa dia berlaku dekat junction? Sebab junction akan membuatkan kereta tidak bergerak. Okay, apabila ada traffic light, kita akan stop, betul? Kita akan stop. So apabila kenderaan stop, beban daripada kenderaan itu akan terus pergi ke bawah. Unlike that, kalau moving vehicles, kalau kenderaan yang bergerak, load dia tidaklah sekuat seperti vehicles that slow moving or stop. Okay, that's why apabila dekat junction kita lihat defect yang memang akan selalu berlaku compare dengan jalan lurus yang tidak ada traffic jam. Okay, so saya dah melelat sikit, tak apa. So we go to the flexible pavement first. So the first types of pavement is flexible pavement. So this flexible pavement will transmit the load from the wheel, from your vehicles to the lower layers, layer by layer, because flexible pavement we have a lot of layers. Okay. Kita lihat ada tak dalam. So it's rigid. Okay, this is a flexible pavement layer. Kalau kamu lihat dekat screen, it start with the subgrade. Okay, paling bawah itu adalah subgrade, seperti mana yang saya cakap tadi. Subgrade is the lowest layer in a flexible pavement, and then it above the subgrade we have sub-base course. Above the sub-base kita ada base course. Above base course kita ada binder course, and then last kali kita ada surface course. So these are the layers that you should know. Okay, you should remember untuk flexible pavement. Okay, so taking advantage of this stress distribution characteristic, flexible pavement normally has many layers, as being shown dekat slide awak. So the design of the flexible pavement uses the concept of layer system. Okay, macam kek lapis lah, dia ada berlayer-layer. So based on this flexible pavement, it may be constructed in number of layers, and the top layer has to be best quality to sustain, to remain the maximum compressive stress ataupun maximum compressive load. So in addition to wear and tear lah. So maksudnya the upper part of the layers, which is the the surface ataupun the the top layer mestilah mempunyai compressive stress, the ability to withstand the compressive stress, and then the ability for wear and tear lah. Okay, so then the flexible pavement, I repeat again, the flexible pavement are constructed using bituminous material. Ingatlah, bituminous material, which is tar lah, okay, ataupun asphalt. And then the flexible pavement layers reflect the deformation of the lower layers to the surface layer. And then in the case of flexible pavement, the design is based on overall performance of flexible pavement, and the stress produced should be kept well below the allowable stress of each pavement layer. Okay, so under flexible pavement kita ada bermacam-macam jenis flexible pavement. Okay, they are, the first one kita panggilnya sebagai conventional layer flexible pavement. The second one is the full depth asphalt pavement, and then the third one is the rock asphalt mat ataupun content rock asphalt mat. You can search lah, CRAM, content rock batu asphalt mat. Mat is mat, carpet lah, mat. Okay. So what is the conventional flexible pavement? They are layered system with high quality and expensive materials that are placed in top of where stress are high, and low quality cheap materials are placed in lower layers. So maksudnya quality material yang bagus kita akan letak di atas, dan quality barang ataupun quality material yang kurang kita akan letakkan di bahagian bawah. Okay, ada layer dekat bawah. And then macam ni lah, this is contoh conventional. Okay, ini adalah traditional flexible pavement. And then we also have full depth asphalt pavement. So ini kalau dia cakap full depth asphalt pavement, maksudnya dia tidak ada sub base, dia tidak ada base. Dia fully menggunakan bituminous material ataupun dia menggunakan asphalt bituminous. Dia akan lay on top of the subgrade. Okay, you dah buat subgrade, which is your soil. Okay, and then dia teruskan letak the bituminous asphalt on top of it. Okay, and then the third one is CRAM, ataupun content rock asphalt mat that are constructed by placing ataupun laid the dense ataupun open graded aggregate layers in between two asphalt layers. So maksudnya in between two bituminous asphalt, kamu akan letak lagi one layer of aggregate ataupun batu-batu. Okay, so modified dense grade asphalt concrete is placed above the subgrade will significantly reduce the vertical compressive. So this one is kalau kita ada situation where the soil is not strong enough, so you can also implement ataupun apply this kind of system ataupun types of flexible pavement. So basically there are three types of flexible pavement. I repeat, the first one is the conventional that are usually being applied in our road construction. The second one is the full depth asphalt, where you are using only bituminous asphalt on top of your subgrade. And then last one adalah content rock asphalt mats, where there are one layer of aggregate in between two bituminous materials. So that are the types of asphalt pavement. So I think kalau kamu lihat gambar rajah ini, the cross section of a flexible pavement, awak mesti nak tahu what is actually natural subgrade ataupun compacted subgrade. So what is sub-base cost, what is base cost, what is binder cost, what is the surface cost, what is the prime coat, what is the tape coat, what is the seal coat. So we begin with the top layer, which is the seal coat. Seal coat ini adalah coating. Okay, you spray the material on top of your surface cost. So seal coat is a thin surface treatment. Okay, is a part of a surface treatment used to waterproof the surface. Okay, and then apart from providing a waterproof surface, it also provide skid resistance. Okay, so that is a seal coat. So seal coat memang adalah satu material yang kita akan lay ataupun kita akan spray on top of the surface cost kelak. Okay, and then of course the surface cost. What is the surface cost? Surface cost is the layer directly in contact with traffic loads lah. Okay, apa yang kamu lihat color hitam ataupun color grey dekat atas jalan itulah surface cost, which is made from asphalt bituminous ataupun tar. So it provides the characteristic such as a good friction, a smoothness, and then And it also prevent the entrance of excessive quantities of surface water into the below ataupun the lower layer of the flexible pavement. All right, so that is the surface cost, and then we go to the next one is tech coat. So also tech coat is a material that you have to spray on top of the binder cost. So tech coat is very light application of asphalt. It made from asphalt. Okay, tech coat dia color hitam. And then usually asphalt emulsion diluted with water. So kadang-kadang dia akan campur sedikit dengan air, and then it provides proper bonding between two layers of binder cost. Okay, kalau awak lihat di sini, tech coat dia akan dispray atas binder cost. Okay, sebab apa? Sebab dia nak they want to produce a good bonding between the binder cost dengan surface cost. Okay. Sebab takut nanti kalau you tak lay the tech coat, the surface cost dia tidak akan bercantum dengan the binder cost below it, right? So and then it provides proper bonding, okay, like I said, between two layer, and then uniformly cover the entire surface and set very fast. So maksudnya apabila you lay the tech coat, kadar pengeringan ataupun kadar pelekatan, okay, kadar dia melekat antara satu sama lain, dia akan lebih cepat. Okay, kalau kita tak letak tech coat, okay. That's why apabila kamu lihat, kalau kamu observe lah road construction, kadang-kadang atas batu dia akan lay a coat, okay, color hitam. Okay, dia selalunya spray lah, dia spray that material on top of the aggregate. So it serve a few purpose lah. So that is for tech coat. And then so what is binder cost? So binder cost also is made from asphalt. Okay, sama juga made from asphalt, and it doesn't require quality as high as surface cost. Kalau kamu masih ingat tadi saya bagi tahu the lower quality kita akan letak bawah. So that is the binder cost. So the binder cost it's also from asphalt ataupun asphalt konkrit ataupun asphalt tar ataupun asphalt bituminous. So kita akan lay di atas prime coat. After this we see what is a prime coat. Okay, and then prime coat is an application is similar to tech coat. Okay, lebih kurang macam tech coat juga. You have to spray for prime coat, awak kena spray di atas base coat. So base coat itu adalah batu lah. Okay, crusheran. So the prime coat is a low viscous bitumen. Okay, dia tidaklah seperti tech coat, dia kurang sikit. And then to an absorbent surface like granular bases which binds layer is place. So it provide bonding between two layers. Okay, dia akan provide bonding antara base cost which is comprised of crusheran dengan binder cost di atasnya. It is a prime coat. Unlike the tech coat, prime coat it penetrates into the layer below, and then it will fill all the voids and forms a watertight surface. Itu adalah tujuan prime coat. Kalau tech coat tadi dia hanyalah untuk mempercepatkan kadar the bonding effect of binder dengan surface cost. Tetapi untuk prime coat dia lebih kepada fill in all the voids dalam base cost tersebut, and then also untuk to have a good watertight surface lah. Okay, and then the base cost. So base cost is actually layered of batu-batu kecil, crusher stone, ataupun kita boleh menggunakan crushed slag ataupun stabilized materials. Okay, tapi selalunya kita akan gunakan batu-batu kecil lah. So they are specific size of base cost. Okay, and then under base, di bawah base cost kita ada satu layer lagi, kita panggilnya sebagai sub base cost. So this sub base cost is one layer of materials from also the crusheran, okay, ataupun batu-batu, tetapi different size. Okay, and then each of the layers dia mestilah di-compact. Okay, macam subgrade tanah awak paling bawah tersebut awak kena compact sampai dia memang betul-betul tidak mendap ataupun dia dah memang fill in all the voids inside the soil supaya air tidak akan dapat masuk ke dalam tersebut. And then for the sub-base course, you lay the crusher run, and then you have to compact using the roll compactor, and then also the base course, binder course, and surface course. Semuanya mesti di compact. Awak jangan lay and then biar saja. You must compact. Okay. Alright. So that is a little bit on the flexible pavement. So okay, we move to the rigid pavement. Okay, so dalam rigid pavement tadi saya dah bagi tahu kita menggunakan konkrit, okay, PCC ataupun Portland cement concrete. Okay, and then concrete tersebut kita akan combine with the reinforcement bar, okay, ataupun reinforce kita panggil ni, Allah lupa lah, mesh bar, okay, mesh bar ataupun reinforcement bar. So it can be constructed in a few types. Yang pertamanya adalah jointed plain concrete pavement, plain jointed and reinforced, and then jointed reinforced concrete pavement, continuous reinforced, and then pre-stressed concrete pavement. So there are a few types of rigid pavement. Okay, yang pertamanya kalau kita lihat plain, jointed, unreinforced. So maksudnya kalau unreinforced dia tidak menggunakan besi. Okay, dia hanya memang purely on concrete sahaja without adding any reinforcement bar ataupun mesh bar. So the second one is jointed and reinforced. Maksudnya dia akan menggunakan besi, reinforcement bar ataupun mesh bar. And then last one adalah continuously reinforced. Okay, yang tadi dia macam jointed, so yang ni dia continuously. So what is jointed plain concrete pavement? So plain cement concrete pavement that are constructed with closely space contraction joint. So dowel bar ataupun mesh bar or aggregate interlocks are normally used for load transfer across the joint. Okay, so selalunya antara satu joint dengan satu joint yang lain kita akan menggunakan dowel bar lah. So untuk menguatkan the bonding between one section to another section. Okay. And then what we have now is jointed reinforced. Tadi plain, tadi adalah plain. Sekarang ni kita menggunakan reinforced concrete pavement. So reinforced concrete pavement ini kita memang menggunakan the whole stretch of your road menggunakan dowel bar ataupun menggunakan reinforcement bar. Okay. So and then the continuous reinforcement concrete pavement adalah where is a system, benda yang sama, kamu akan gunakan concrete and then you akan gunakan reinforcement bar, but the way you construct the pavement is a bit different from the jointed reinforced concrete pavement. Okay. So after that this one is the contoh rigid pavement. Apabila awak lihat di sini, this is the reinforcement bar. Okay, reinforcement bar. And then apabila kamu lihat di sini, ini adalah dowel bar. So maksudnya jointed adalah dia join antara satu section dengan satu section yang lain. Dia tidak akan buat the whole this one sekali. Tak, dia akan section by section. So that's why from section to one section another section, awak kena letakkan dowel bar lah untuk for binding purpose lah. Okay, and then after you dah you dah concrete, then you akan buat scraping sikit lah supaya permukaan yang akan kasar sedikit. Okay, this is the gambar aja diagram for rigid pavement. Just a simple diagram for you to understand how does it looks like. Okay, this one I have explained. Okay, so pavement materials. So saya dah bagi tahu tadi lah. So pavement materials is only for the surface part of the pavement. Sebab untuk subbase, base course, subbase course itu adalah daripada crusheran. Tetapi untuk surface materials, it is a special mix materials. So yang pertamanya adalah kita menggunakan asphalt semen ataupun asphalt tar. So it's a sticky black material used in pavement seperti yang awak selalu lihat as you guys observe during the construction of a road. So kita selalunya panggil dia sebagai tar, jalan tar. Okay, so kita kalau nama spesifiknya adalah asphalt lah. Okay, asphalt ataupun bitumen ataupun kita panggil sebagai binder. So it is a cementitious material in which predominating constituents are bitumens from the petroleum refining process. So maksudnya it's a cementitious materials which most of the materials, the percentage, high percentage of materials comes from the bitumens. So bitumens ni datang daripada petroleum punya proses lah, refining process. Yang kali hitam. So the asphalt cement ataupun asphalt has a characteristic of consistency, purity and safety. That's why kita menggunakan asphalt untuk buat flexible pavement. Okay, that's why this is a very a good materials that should be applied for road construction ataupun road surface. Okay, rather apart from this one, saya tak recommend lah. Okay, this is the most suitable materials. And then next one is ini adalah contohnya lah. Okay, ini adalah contoh bitumen tadi. So this bitumen dia akan campur dengan batu-batu kecil. Okay, crusheran lah, batu-batu kecil. Memang dia ada specific size. That's why dia akan jadi asphalt cement. So ini adalah gambar bitumen, cecair bitumen hitam daripada refining process of petroleum. So this one kita akan campur dengan batu-batu tadi. Okay, kita akan buatnya dalam premix plant. Benda tersebutlah akan awak lay atas permukaan jalan. Okay, bukannya hanya bitumen lah. Jangan awak lay bitumen nanti lain jadinya. Okay. The next one is a chip seal. So apakah chip seal? So chip seal is a non-structural layer placed on the pavement to provide high friction, low maintenance cost surface. Okay, to build chip seal, asphalt cement will be spread on the existing pavement and the single size stone chips are spread uniformly on asphalt cement and compacted. Ini dia menggunakan kaedah yang berbeza. Dia akan menggunakan asphalt cement ataupun the cecair of asphalt. Dia akan spray di atas jalan and then dia akan taburkan batu kecil di atas layer spray tadi. So dia spray dulu, spray the asphalt atas permukaan jalan and then baru dia akan letak another material which is a small size of stone chips. Okay, yang dia akan letak atas jalan, then awak akan compact. So this one is very cost efficient, tetapi dia tidak kuat. Dia murah and then dia usually being used dekat kawasan-kawasan luar bandar lah ataupun kawasan-kawasan yang jauh daripada city lah, kawasan-kawasan pedalaman, sebab dia murah dan juga sesuai untuk kegunaan traffic yang tidak banyak. Okay, tetapi for chip seals dia ada masalah because the surface will be rough, dia tidak smooth. Okay, and then apabila dia rough, dia akan produce a lot of noise at any speed. Okay, tak kisahlah speed slow kan laju kah, dia akan produce a noise lah. Okay, unacceptable level of noise. That is for chip seal. Saya rasa saya ada gambar. Inilah contoh chip seal. Apabila awak lihat chip seal ini permukaannya tidak smooth, dia kasar. Okay, when you look at the first image dekat sebelah kiri on the left side of your slide, awak akan lihat a layer of minyak. This one is asphalt yang dia akan spray, and then apabila dia dah spray asphalt, baru dah dia akan letak the chip seal. Okay, the chip seal dia akan taburkan di atas minyak tersebut, then they compact the chip seal. So chip seal akan melekat terus ke atas material asphalt tersebut. So dia akan jadi macam yang gambar ada di bawah. Okay, dia akan jadi rough. Yang ini memang tidak sesuai kalau awak nak buat dekat jalan-jalan di bandar lah. Okay, nanti dia bising, and then awak punya tayar akan cepat rosak, kena tukar selalu sebab the friction is too high. Keadaan jalan yang agak kasar akan mengakibatkan bunga tayar awak akan cepat hilang. Okay. So last one is PCC. Saya dah bagi tahu tadi, PCC is the combination of concrete, okay, with the reinforcement bar. So I guess that's all for today's class. It's more than 1.5 hours for this lecture. So maybe we can proceed with the presentation from representative ataupun selected groups for this course. So before we proceed with our presentation, if you have any question, you may ask now lah. Okay. So everyone okay kah? Are you guys still depan komputer?
Yes, sir.
Yes, sir.
Ada, sir.
Mungkin awak ada yang mengantuk dan tertidur, saya faham.
Pun Christmas baru nak mula, sir.
Apa, Ezra?
Pun Christmas baru nak mula, sir.
Okay lah. Okay. Saya faham. So, if you don't have any questions, so kita proceed dengan a short presentation by each of the groups. Boleh kah?
Boleh, sir.
Alright. So we start with siapa yang nak volunteer dulu? Nak present? 5 minutes only, okay? Just less than 5 minutes is
My group lah, sir.
Okay. Sekejap saya stop present.
Okay.
Okay. The floor is yours now.
Sekejap. Cuba untuk...
Oh. Lama saya nak buka Ezra.
Apa khabar, sir?
Ya, awak makin berisi ya.
Yes. Stay at home. Sebab tu berisi. Sir, dapat nampak kah?
Boleh.
Okay.
Clear.
Right. So it's been a while we did not present anything, so I think this is a presentation for this semester. And before that, I would like to wish Merry Christmas to those celebrating. And today I would like to present about cantilever retaining wall. So the content will be design of cantilever. I will explain a little bit about design of cantilever retaining wall, and then second is the construction method. And we start with cantilever, the design. So usually the retaining cantilever retaining wall, the function just like a door stopper. I hope anyone understand what kind of door stopper, just like your door, and then you put a stopper at the door to avoid it to move when the wind push it. So here, retaining wall used to hold back soil, just like the idea just now I explained, and it has thin stem and base slab, heel and toe. So this is the stem, and this is the toe slab, heel slab. This is the earth soil that you need to hold. So next is reinforced concrete, precast concrete off-site manufactured at concrete facility or pre-stressed concrete site cast in situ or on-site, whether it can be manufactured at the factory or can be at the site, can be built at the site also. The shape will be in two types. First is T shape or L shape. It is inverted. That means terbalik lah. Just like this one is T shape. Okay. So next, okay, this is, if I'm not mistaken, this kind of term will be used in civil engineering. They use this kind of term to calculate the force that need to be designed on the retaining wall. Just like basically we start from this number one, height of earth to be retained, height. I think the height of the retaining wall, then subcharge pressure of on backfill. That means the pressure from the backfill that fill macam mana dekat belakang retaining wall tu, sebab dia nak tahan backfill tu. And the angle of internal friction of soil, I don't know what kind of symbol is this. I think they have this kind of formula that they need to be calculated. And then slope of backfill. And then 5 is unit weight of soil. The unit will be kilonewton per meter square. And then 6 is soil wall interface friction. Lastly, concrete density in kilonewton meter square. So, this is the point that I'm looking forward, the method of how to construct a retaining wall. So first is prefabricating the reinforced steel. Second, fill excavating an even greater volume of the earth bank, making more difficult wood form for both sides of the wall. Placing and tying in place the reinforcing steel, pouring the concrete, removing the wood form and resurfacing the exposed concrete surface. 7. Backfilling the excavated earth of the bank, providing expansion joint and weep hole in the wall. 9 is allowing time for the setting of the concrete before removal of the wood form and making the backfill. Alright, before I would like to end my presentation, I would like to show you one video how people build it. The video will be around 1 minute 47 seconds.
Okay.
Semua boleh nampak kah video ni?
Boleh.
Okay.
So this one is in situ lah.
Yes, this one is in situ.
Right.
And for your information, this is a L shape. Sorry, T shape, inverted T shape retaining wall. thank you. That's all from me.
Okay, thank you very much, Ezra. Just to add a bit from your presentation. So supposedly time dia tengah construct the stem of the the retaining wall, kan dia akan pasang formwork dulu kan. They should install a formwork dekat stem, and then the the side of the face side of the soil that have to be backfilled, dia akan letak satu temporary support from the formwork of the step terus pergi ke soil that that is next to the retaining wall lah, the proposed retaining wall. So kalau you tak ada temporary support, nanti you tak boleh buat concrete works. So that one is not being shown dalam video awak tadi lah. Okay. Alright, thank you, Ezra.
Okay, welcome, sir.
So next group, please. Next group. Siapa nak start? Hello.
Hello?
Di.
Kejap. Saya cari slide.
Slide hilang.
Macam mana nak buka slide je, sir?
Ezra.
Sorry.
Alright, okay lah. You can share your slide now lah.
Alright.
Tekan apa, sir?
Dekat bawah tu dia ada button open share tray. Sebelah mikrofon. Sebelah mikrofon.
Share content ni. Oh.
Yes.
Nampak ke?
Nampak?
Sekejap. Boleh full screen ke, sir?
Oh, tak apalah. Kalau ni pun okey.
Tak reti lah full screen.
Ini PDF kan?
Apa?
Yang ni PDF kan? Tak apa. Okey. Boleh tengok.
Okey.
Syirah cakap F10. F10. F11.
F11. Macam ni je.
Oh. Macam tu juga. Tak apalah. Proceed lah.
Okey. Nak tengok muka saya ke?
Kalau awak share memang tak boleh tengok ah. Awak share apa ni? Awak share screen kan? Awak share screen muka memang off kan? Automatically off.
Tak apalah.
Tak apa.
Okay. Assalamualaikum and good evening.
Salam.
So we're going to present about construction method of vertical cantilever precast retaining wall. So the first step is to excavate to receive foundation as per drawing. So just like just now Ezra's, kuat pula bunyi motor.
Ada racing ya?
Itu lah, rumah saya tepi jalan je.
Oh, okey.
Orang balik kerja je.
Okay.
Okay.
Balik je.
So the second step is to pour concrete in the foundation strip, just like we study in the construction measurement lah. The steps to ensure the strip is level both along foundation and across. Do not allow the concrete to rise to the edge. If not, the precast will be not level lah. And then step 3 is to set out string lines. Set up approximately 10 mm away from outside wall to avoid being pushed up during installation. So this is also to ensure the vertical wall is balanced along the planes so that it will not be slanting or sengit.
Okay.
And then the step 4 is to unload the panel. Unload panel using suitable loader or cranes, and on rack off on level ground as shown in drawing. This means that we have to use the suitable crane or loader, and for the next step we will show you the this one ke? Maksudnya to avoid kerosakan lah kepada panel tu, so we have to use the suitable machineries lah.
So this one is what
Yes, sir.
for?
Yes sir.
The panel is for what, Adi?
The cantilever, the retaining wall, but this one is a precast concrete.
Okay. So that one is ada punya formwork kan?
Tak dengar sir. Yep.
Is that a formwork?
Is there a formwork?
Is that a formwork? Yang
Which
awak plate yang atas tadi. The one
Which
that
one?
you showed before, yang atas. Step 4.
Oh, step 4. Yang ni.
Awak. Okay, yang this one. Unload panel. So what panels is this?
The panels for tu lah apa?
Oh, this one is the section.
Aha.
Oh. Okay, saya ingatkan dia macam papan ke apa?
Inilah panel.
Okay. It's stacking on top of each other lah.
Yeah.
Okay. Right. Boleh.
Okay. And then next.
Thank you, Hana.
Step 5 is to set out cradles. Start at the corner to the nearest and highest point of foundation. Position the cradles on joint between panels. Cradles ni, you all tahu ke cradles ni apa?
Cradles of field. Tak tahu. Cradles.
Saya ada cari semalam. Sekejap. Cradles.
Oh, ni baru nak cari ni.
Tak.
Ni lah kantoi ya. Apa Hana? What is cradles? Tolong Hadi. Siapa dia?
Hello. Cradles tu macam tahu tak, macam tempat orang selamatkan orang bomba selamatkan orang dekat tingkat atas kalau ada kebakaran tu.
Yang mana satu
Dia segi 4 se.
Oh, atasnya
Lepas tu digantung, dia macam ada tali. Macam kalau cuci tingkap dekat luar tu.
Oh, okay,
Faham
okay.
tak?
Oh, faham.
Ah.
Okay. Adi, next.
Hello.
Ha.
Step 6 is position first panel and lifting holes of loop cast in the panel. Lifting holes ni tempat kita nak gantung kabel tu is actually attached to the panel lah, so that we can lift the whole panel using the loops.
Okay.
Okay. Ensure the first panel is at correct position and vertical or plane. So, okay, secure the position using anchor bolts. Anchor bolts ni is actually an expanding bolt, which when we install it to a material, to a concrete items, so when we secure it in place, the bolts will actually expand and secure itself on the concrete lah.
So dia macam a connection lah.
Yes, instead of kita join the traditional way, the bolt yang anchor ni they actually expand.
Oh, okay.
So more secure.
Right.
And then step 7 is to install the remaining panels. Yang dekat gambar belah kiri ni is actually a prop system.
Yes. It's a
Prop system.
temporary.
Nama dia RMD. Dia rake and pull macam tu nama dia. So that dia macam as a extra support to the wall.
Okay.
So step 8 is to ensure all panel are level. Check the top height as well go on. This may slight variation. So the 6 mm is the allowance for the variation lah on the top of the retaining wall. So step 9 is to pour foundation concrete, and then the usual work to remove air and ensure filling beneath the panels. And do not pour too much concrete on one side at times, as the panel can be displaced. So the step 10 is to pour floor concrete slab. Floor concrete ni is the bottom part, as you can see in here.
Okay, the base lah.
The bottom part. So actually the floor concrete will also increase the structure rigidity of the retaining wall, so it can retain more load from the other side.
Okay.
And then step 11 is to seal the joints, and then seal the joints means to fill up any gaps, and sometimes we use packer tools. Packer tools can differ. One of it is an asbestos piece. Packer tools is actually the things that we use to remove the gap. It's not actually remove, it's actually to fill in the gap that that is there. Yes. So step 12 is to fill lifting holes and any area damage during installation. Installation lifting holes ni is that yang kita dah the first study tu, yang kita ikat untuk angkat dia tu. So that thing kita kena uninstall, and then we have to fill in the holes lah.
Okay.
And then step 13 is to backfill. Backfill means to kambus balik that site yang foundation apa tu semua kita kambus balik.
Okay.
So yeah, that's all.
Alright. Thank you, Hadi, for the presentation. So next group, please. Oh. Cari apa? Cari router.
Wi-Fi tak sampai bilik tu.
Beli router baru lah.
Itulah.
Beli ni Asus.
Asus mahal lah tu.
Dia bagus.
Itu lah. Nanti ada rezeki saya cari.
Okay. Shopee kan ada. So next group please.
Sir, can you hear me?
Yes. Ini.
Yeah, I think my group will present now.
Okay. Please.
Okay, I think I should start.
All right.
A very good afternoon to Sir Wafi and all my classmates. Today we would like to present about the fabrication process of precast cantilever retaining wall. So the first process is assembly of steel mold. Before the steel mold is arranged and attached together for panel casting, the flatness for the base of the steel mold is measured with measuring tape so that the surface of the cantilever retaining wall is even. The accuracy of the dimension and squareness of the steel mold is checked to ensure that it is arranged according to the design and within the specified tolerance that has been controlled to avoid any possible defects. And the second process is preparation of steel mold. The old mortars and debris attached to the steel mold is then cleaned and removed by using the scaling bars. The special composition such as foam oil is then applied evenly onto the surface of the steel mold to prevent the concrete mixture from sticking and thus ensure the smooth surface of the cantilever retaining wall after the concrete mixture has been cured. The joint and edges of the steel mold, rubber, seal, tie rods, side props, bolts, stoppers are checked and locked properly to ensure that the steel mold is fully secure and rigid. So next, I would like to invite Kwan to present the next process.
Hi everyone, I'm Kwan. So I'm going to present the next step, which is the fixing of rebars. So before placing the rebars, the size, the spacing, and lap length of the rebars have to be checked according to the drawing. So we have to make sure the rebars and other casting items are positioned and secured properly. After that, we are going to place the spacer with sufficient number and correct size. Then we are going to carry out the strand holding. So now I'm going to leave the presentation to Linda.
Yes, the fourth step is doing a final inspection before casting. Before casting precast concrete, all details such as mold reinforcement bar must be checked and confirmed to comply the requirement of the engineering drawing. The accessory condition of the mold that include the blockout detail must also be checked to avoid big problem due to a part or mold fitting error. Besides that, the base mold level also need a check, especially for a site precasting. This because the mold level may be changed due to other concurrent site activity are ongoing at the same time. The next step is concreting. After the inspection, the concreting work will be prepared. The concrete grade that used must be checked according to the design specification. Before placing the concrete in the mold, the workability of the concrete mix must be assessed by using conduct slam test, which is complied with SS78. Furthermore, the drop height of the concrete mix must be ensured not exceeding 1 meter. After that, for the congestion area in mold can use the vibration and compaction to ensure the concrete can be fulfilled and reach the desired place. After the initial step, the concrete surface level will be start to spread and level with maintaining the required thickness of the surface by using the squeezer. Next, I would like to invite the Shija.
Hello.
Yes, Shizat.
Hello, sir. Okay, the next stage is the curing stage. So during this stage, we need to make sure that the curing time is appropriate and is also within the desired environment. Other than that, the curing conditions surrounding the concrete cube should also be the same as the precast concrete elements. The reason why is because if the curing conditions are not the same, then you might not get the results that you want. So the next step is demolding. Cube tests should be carried out to verify the concrete strength of elements before the demolding process. And usually it is important to make sure that for reinforced precast elements and pre-stressed precast elements that they have at least concrete strengths of 10 Newton per millimeter square and 25 Newton per millimeter square respectively. After that, we need to remove all the bolts, pins, and side mold forms before lifting them. And as for pre-stressed elements, the strands are cut before lifting. Alright, so next.
Hi sir, I'm Vong. I will present the last step, which is final checkout and move to warehouse. So the condition of the final product is examined by the person in charge. For example, the crucial dimension is needed to be checked to improve the quality of the product. Next, locate correct identification labeling on the elements as stated in the drawing, such as type, size, weight, orientation. Lastly, verify the elements that have reached 75% of their desired concrete strength before supplying to site for construction. This is because we need to ensure the quality of the precast product is reached to the desired level. So to conclude, the fabrication process of precast cantilever retaining wall involved 8 steps based on our finding. So that is all from us. Thank you.
Right. Thank you, Annie. Thank you, Shizat. Thank you, Kwan, and thank you, Vong, for the nice presentation. So I think that is more specific on the precast retaining wall rather than the presentation before this. So that's a good job, actually. So maybe you can share the presentation to your friends, all your friends. Huh? Right. So the next group, please. Hello, next group.
It's my group's turn, sir.
Huh?
It's my group turn.
Oh, okay, okay, okay.
Okay. Okay, I will start my presentation for today. Good afternoon, everyone. So the presentation for today is about cantilever retaining wall. And for the content, next slide.
Next slide.
Okay, for the content, we will talk about the construction method, the design process, as well as how to ensure the quality of this cantilever retaining wall. Okay, for the introduction. The cantilever retaining wall is the most common type of retaining structure, generally economical for heights up to 8 meters. It is also consists of vertical stem, a base slab, made up of two distinct regions, a heel slab and as well as cantilever retaining wall, which is in situ cantilever retaining wall and precast. But for my group, we will focusing more on in situ cantilever retaining wall.
Okay.
The next one will be the construction method.
Next slide.
For the method of construction, method is likewise relatively complicated, which include prefabricating the reinforcing steel, field excavating an even greater volume of the earth bank. The third one will be the making more difficult wood forms for both sides of the wall, placing and tying in place the reinforcing steel and surfacing the exposed concrete surface, backfilling the excavated earth of the bank, providing expansion joint and weep holes in the wall, and lastly allowing time for the setting of the concrete before removal of the wood form and making the backfill.
Okay.
Move on to the design consideration. For the design consideration, for the first one, we will select the overall dimension, which include the height, embedment, footing length and position, as well as estimated footing and wall thickness, which based on the stability, which refer to the sliding and overturning, and soil strength. The second one will be the check slab, which is wall and footing, thickness using shear criteria, and factored loads, adjust thickness as necessary, rechecking stability and soil strength of the value change. The third one will be select the temperature and shrinkage steel for wall and footing. And last one will be the select the flexural steel for the 3 cantilever slabs element using factor loads. Okay, this is how we're going to ensure the quality of the cantilever retaining wall. So the first one will undergo site inspection, QA/QC. Second is to make sure rebar and concrete spacing is as per drawing, and together with the concrete, which is really important. And also to make sure proper casting procedure use of vibrator poker to avoid any honeycomb. And last one is checking the concrete to ensure concrete strength is correct and suitable. So that's all from me and my groups. Thank you.
All right. Thank you, Priscilla. Thank you for the presentation. So this one is for in situ retaining wall, concrete retaining wall, cantilever retaining wall. Sorry. So thank you for the nice presentation, and I hope you can share the presentation to all of your friends. Okay. So next group, please. So far we have 4 groups that have presented their works. Next group siapa lagi?
So group saya dulu.
Okay, Kekon.
So group will present about cantilever retaining wall, cast in situ one. So, it's more or less like extra group punya lah. So,
Okay.
so start with the characteristic of the cantilever retaining wall. It is in an inverted alphabet T, has thin stem and base slab, and then made from steel reinforcement and concrete. Function is to transfer horizontal pressure from behind the wall to vertical pressure on the ground below. So to refer from extra punya presentation just now, there Ada mentioned the height of the cantilever and those, right? To add in, yeah, we also have to the civil engineer also have to determine the safety factor of the overturning and sliding of the retaining wall. So the minimum is about 1.5 lah. If lesser than 1.5, then the overturning and sliding will occur, which means the retaining wall fail. Next, the construction method. First, we'll do the excavation work. An area that equals to the base of the wall is excavated. excavated, then we place the formwork and reinforcement steel for the base first. Then we pour the concrete inside the formwork for the base. After the cure process, then we work for the vertical part of the cantilever retaining wall. So again, we place the formwork and the reinforcement steel for the stand. Then we pour the concrete inside the stand, wait for the curing process again, and then cabut the formwork. Then we place the backfill for the retaining wall. That's it.
So after you backfill, do you have to compact the soil? Backfill. Okay.
Yeah.
Right. Okay. So thank you. Thank you, Con, for the presentation. So very simple and yet informative lah. Okay. Nanti saya akan buka satu link for you to upload your presentation slide lah. Okay. So next group, please.
Hi, sir.
Hi, Man.
Hi. Group.
Okay. All right.
Alright. Our group going to present construction method of precast cantilever retaining wall.
Okay.
Sama macam Ezra juga.
Ezra in situ.
Bukan. Precast. Hadi sama dengan Hadi.
Hadi and Kwan.
Okay, firstly, site preparation is prepared by ready access rod dengan excavating the site, clear pokok dengan rumput semua siap lah. Second, the crane truck akan datang bawa cantilever retaining wall and then the crane akan handling and positioning the cantilever retaining wall. Third, cantilever retaining wall is level before start grouting. Mereka akan levelkan every cantilever sama lah. Dia boleh ada lari sikit. Pasal fourth, cement grout is used to fill gaps between two cantilever retaining wall to ensure uniform contact. So mereka akan cement between the cantilever retaining wall lah, sebab betweennya ada gap. Fifth, backfilling the excavated earth of the bank. Mereka akan kat tanah kat belakang lah, tapuk balik. Sixth, they can start compact by using compactor until achieving certain soil bearing capacity that required by the engineer. The last step is surface protection by hydro seeding is conducted after backfilling achieve a certain soil bearing capacity that required by the engineer. Mereka akan siram hydro seeding lah saat rumput senang tumbuh. We're gonna show you the video of how cantilever retaining wall dibuat dekat kilang.
Okay.
Old Castle infrastructure leverages decades of experience and a
Video, 5 minutes.
structure today. With a nationwide network of precast facilities, our products are used in a number of markets under all hand. In this video, you scenes look at one of our plants and gain first-hand experience on Old Castle Infrastructure's precast manufacturing process. Follow along as we take a closer look. The process starts with engineering. Every product is engineered using the latest design tools, and detailed drawings are created using a 3D computer-aided design process. Once design drawings are approved, they are sent to the factory floor and used to monitor production. Ensure proper clearance of reinforcing. Once the cage assembly is complete, we can begin to prepare and clean the form. Old Castle infrastructure uses a variety of steel forms, which are built to last and will maintain exacting tolerances for more than 30 years. Care is taken to ensure that the reinforcing cage is stable for transport to the form. Once setup is complete, a certified quality control technician will conduct a pre-pour inspection to ensure conformance with the approved shop drawing. Upon satisfactory completion of this inspection, the technician will sign off and flag the form indicating approval to place concrete. Old Castle infrastructure uses a variety of certified raw material sources, including cement, coarse aggregates, sand, and chemical admixtures, which are carefully selected and mixed according to the specific design requirements. Each Old Castle infrastructure precast factory has a concrete laboratory used to conduct routine raw material testing and control exact quantities for each batch. This is where it begins. This may include tarping the product overnight in order to capture the heat hydration process. The controlled environment of a precast factory enables the product to properly cure and reach the full design strength. Once the QC technician confirms that the product has reached the desired strip strength of 2,500 to 3,000 psi, then the stripping process may begin. Care is taken to make sure it is stored on proper dunnage as it awaits the customer demand. When the customer is ready to receive the order, the product is loaded on the truck and properly tied down for shipment and delivery to the project site. To learn more about Old Castle infrastructure.
That's all from us.
Okay.
Thank
Thank
you.
you. Thank you, Rahman, for the presentation. So your slide tadi, your apa nama infographic presentation is all about the arrangement or the installation part for the cantilever retaining wall. And then for the video that you showed to us is quite similar with what have been explained by group Kwan tadi lah. Okay, so all right, thank you very much. So next group, please. Ada group lain nggak? Oh, dah settle semua dah. There are 5 groups that have presented the task. Okay, if there is no more group to present, so I think we can dismiss our class for today. And I hope I can see you again next week, continuing our part 2, apa nama, part 2 for road and pavement topic. Then thank you for attending.
Sir?
Sir? Yes.
Saya nak tanya, next week we start the class hari Selasa kah atau hari Kamis?
We stick to Kamis dulu lah.
Oh.
Are you okay? Are you okay with Kamis?
Okay. I just want to confirm with you.
Okay. We do it Kamis lah.
Okay. Next week also Kamis same time lah.
Yes, same time. Pukul 2.
Alright. Thank you.
Okay.
Thanks for the question.
Alright, thank you. Okay, thank you for attending.